In this module, we will look at the ATR's fuel system. We will start out with the system description. In the system description, you will learn about the general layout of the fuel system, the fuel vent system, aircraft refueling, as well as the operation of the electric fuel pumps and the jet pumps. Next, we will look at the controls and indicators associated with the fuel system. The fuel system of the ATR consists of two integral wing tanks: the vent system, the fuel quantity indicating system, the pump systems, the distribution system, and the refuel/defuel system. Each wing tank can hold up to 2,500 kilograms of fuel. The wing tank incorporates a feeder tank located near the wing root. The feeder tank holds 160 kilograms of fuel and houses an electrically driven fuel pump and a jet pump. Feeder tanks are used to ensure fuel is available for pumping throughout all flight maneuvers. The maximum fuel imbalance between the fuel tanks is 730 kilograms. Two fuel lines pass through the wing center box located over the fuselage. One line is used to cross-feed the engines, and the other line is used to refuel the left tank. Two drains at the bottom of the box drain any fuel that may have accumulated in the center box. In addition, a vent line prevents any concentration of fuel vapors. A vent system provides a positive pressure on the fuel in the tanks when the aircraft is pitching and rolling. Each wing tank incorporates a vent surge tank located on the outboard section of each wing tank. Each tank is vented through an individual vent duct to the associated vent surge tank. A flush NACA inlet provides atmospheric pressure to the surge tank and prevents the accumulation of ice on the surge tank inlet. NACA vents are also designed to resist lightning discharge. A float valve allows fuel to collect into the surge tank. In turn, fuel that is collected in the surge tank is returned to the wing tank through the associated vent duct. Another function of the vent system is to prevent an overfilling of the fuel tanks during refueling operations. In the event a tank is overfilled, fuel will be discharged overboard through the surge tank inlet. The wing tanks are normally refueled using a single-point refueling system. In addition, there are two filling caps located on top of the wing tanks in order to provide a way to gravity refuel the aircraft. A refueling control panel located in the right main landing gear fairing controls the refueling operation. The aircraft can be completely refueled in approximately 16 minutes. The aircraft is refueled by connecting a refuel line to a single refueling connector located on the rear part of the right main landing gear fairing. Once connected to the refueling connector, a positive pressure is applied to the fuel to push the fuel into the wing tanks. Maximum pressure for fueling is 50 psi. When refueling, certain things should be avoided. Make sure no switches are operated, particularly activating or deactivating the GPU. Smoking should obviously be avoided, as well as the use of cell phones. Also take care not to refuel with any thunderstorms in the area. Two refuel valves located downstream of the refuel connector control the flow of fuel to each associated wing tank. These valves are solenoid controlled. Once the refuel valves are opened, fuel flows to the associated tank. Fuel is dispensed into each tank through diffusers. Normally, the fuel quantity indicating system controls the closure of the refuel valves. The fuel quantity indicating system closes a refuel valve when the fuel quantity in the associated wing tank reaches 2,500 kilograms. Level sensors in each tank control the associated refuel valve in the event of a malfunction of the high fuel level detection system of the fuel quantity indicating system. Each tank incorporates two fuel level sensors located on the upper wing skin. When the fuel tank is full, the sensor is submerged and it will command the associated refuel valve to close. The aircraft can be defueled using the single-point refueling system. Defueling is accomplished by applying a negative 11 psi pressure to the refueling line and opening the refuel valves. Normally, each engine is fed by the feeder tank and the associated wing tank. This feeder tank is kept full at all times to protect the engine feed against negative or lateral load factors. The feeder tank will hold approximately 200 liters of fuel. Each feeder tank incorporates an electric fuel pump and a jet pump. The electric pump is capable of supplying fuel to one engine throughout the entire flight envelope. The electric pumps are powered by the DC essential bus through the associated electric pump circuit breaker. The electric pump and the associated jet pump can supply both engines throughout the whole flight envelope. One jet pump can supply both engines throughout the whole flight envelope except when using Jet B fuel. Normally, the electric pump is only used to start the engine. Once the engine is operating, the engine fuel feed is supplied by the associated jet pump and the electric pump shuts down. Fuel flows out of the electric pump and flows in two directions. The first direction takes it through a check valve and out to the low-pressure fuel valve. During normal flight conditions, the low-pressure valve is in the open position. The low-pressure valve is only closed by pulling the associated fire handle. Electrical power from the DC emergency bus or the associated DC bus is required in order to close the low-pressure valve. Fuel is also directed from the electric pump through a check valve to a jet transfer pump. This pump pulls fuel from the main tank to refill the feeder tank. After the LP valve, fuel then flows through the fuel filter, the fuel heater, and then to the high-pressure fuel pump. This pump is driven off the accessory gearbox, which is driven by the high-pressure compressor. It's important for the HP pump to have some head pressure in order to prevent the pump from cavitating. Fuel then flows through the hydromechanical unit, or HMU, to the engine. Within the HMU, some fuel is returned to the feeder compartment via the motive flow valve. This pressurized fuel provides motive flow for the engine feed jet pump. When sufficient pressure is present at the motive flow valve, it will open and allow fuel through to the jet pump. If the fuel pump push button is deselected, the motive flow valve will not open. The fuel pump push button is deselected when it is not pushed in. Additional fuel is then tapped off the main jet pump and returned through a check valve to the fuel transfer jet pump. This jet pump just transfers fuel to the feeder tank where it can be pumped by the main engine feed jet pumps. A pressure sensor monitors the output of each associated jet pump. If the output of a jet pump drops below 5 psi, the associated electric pump starts automatically, provided the associated pump push button on the fuel control panel is in the depressed or in position. Fuel pressure below 4 psi will be indicated by the illumination of the feed low pressure light. After the jet pump output pressure increases above 8.5 psi, the associated electric pump will automatically stop 30 seconds later. There are two other conditions that will cause the electric pump to start up automatically. As mentioned previously, the automatic operation of an electric pump will occur only if the associated pump push button on the fuel control panel is depressed. The second reason an electric pump would automatically operate is during cross-feed operations. In this situation, both electric pumps will automatically start, provided, of course, that both pump switches are depressed. The third reason an electric pump would start to operate automatically is when the associated feeder tank is not full. The pump will start to run automatically when the fuel quantity in a feeder tank drops below 160 kilograms. This condition will be signaled by the illumination of the low level of light on the fuel quantity indicator. A fuel cross-feed system allows either tank to feed the opposite engine. The two fuel systems are interconnected through a cross-feed valve. The fuel cross-feed valve is controlled by the cross-feed push button on the fuel control panel. The cross-feed valve is powered by the DC essential bus. Fuel cross-feeding is usually used to correct a fuel imbalance. In this particular case, the left tank is lower than the right tank. To balance the tanks, you would depress the cross-feed push button. When the crossfeed push button is depressed, it will turn on both electric fuel pumps. In order to start the crossfeed operation, simply deselect the pump in the tank with the lower fuel quantity. This will leave the tank with the most fuel with 2 pumps running. To stop crossfeed operation, simply select the push button for the pump in the low tank to the run position and deselect the crossfeed push button. The panel on the screen is completely interactive, so you can start to balance the fuel. When the fuel quantity in both tanks are equal, terminate the crossfeed operation. Another situation where you would use the crossfeed valve is for single engine operation. In this situation, the operating engine would draw fuel from both tanks in order to maintain the fuel balance. In this case, you would not shut down any electric pump so that fuel can be supplied by both tanks. A fuel quantity indication system calculates the fuel quantity and displays the fuel quantity in each tank on the fuel quantity panel. This panel is located on the Flight Instruments panel. Fuel quantity is displayed in terms of weight. The fuel quantity system operates on the relationship between the dielectric constant of the fuel and its density. The fuel quantity indicating system produces a signal that is proportional to the mass of the fuel in the tank. The signal is derived from capacitance probes located in each wing tank. There are 6 probes in each tank. The fuel quantity indicating system consists of 2 channels. There is 1 channel for each wing tank. The probes in each tank are electrically connected to the associated flight deck fuel quantity indicator. The 2 fuel quantity indicating channels are independent from each other. In the event of a failure of the electric fuel quantity indicating system, the fuel quantity in each tank can be determined by means of 2 magnetic level indicators. There are 2 magnetic level indicators for each tank, and they are accessed through the bottom of each wing tank. The readings from the magnetic level indicators are used to derive a fuel quantity from a conversion table. The markings on the magnetic indicators are in centimeters of fuel in the tank. The controls and indicators for the fuel system are located on the fuel panel. This panel is on the overhead panel. The fuel panel holds the controls for the electric fuel pumps and the crossfeed function. The arrangement of the push buttons and lights on the control panel along with the lines provide a simplified schematic of the fuel system. The pump push button controls the operation of the associated electric fuel pump and the motive flow valve. When the pump push button is depressed, the associated electric fuel pump will automatically activate when the associated jet pump delivery pressure is low. This can occur either due to the engine not running or the jet pump pressure dropping while the engine is running. The run light illuminates green when the electric pump is activated. When the pump push button is depressed, the associated jet pump motive flow valve is commanded open. However, the valve will remain closed until sufficient fuel pressure is available. The electric fuel pump will automatically shut off 30 seconds after high-pressure fuel is available and the jet pump is operating normally. Operation of the jet pump is determined by a pressure switch. The electric pump will stop running when the pressure from the jet pump exceeds 8.5 psi. This explains why the green run light in the fuel pump push button goes out after engine start. When a pump push button is selected out, the associated electric fuel pump is deactivated. The jet pump motive flow valve is commanded to the closed position, and the off caption in the push button illuminates white. The motive flow valve is closed in order to stop the main jet pump from pumping. The low pressure valve position indicator is located above each. When a pump push button is selected out, the associated electric fuel pump is deactivated. The jet pump motive flow valve is commanded to the closed position, and the off caption in the push button illuminates white. The motive flow valve is closed in order to stop the main jet pump from pumping. The low pressure valve position indicator is located above each pump push button. It indicates the position of the associated low pressure valve. If you recall, this valve is only controlled by the associated fire handle. When the low pressure valve is open, the associated indicator will show a green inline flow bar. When the valve is closed, the associated indicator will show a green crossline flow bar. The flow bar is not visible while the valve is in transit. The schematic on this screen is interactive, so you can pull the fire handles to see the effect on the fuel system diagram and the fuel control panel. The feed low pressure light illuminates when the supply pressure is below 4 psi. This indicates a drop in fuel pressure to the main engine-driven fuel pump due to either a loss of both the electric fuel pump and the associated jet pump, fuel starvation, or a blockage in the supply line. When a feed low pressure light illuminates, a single chime will sound, the master caution lights flash amber, and the fuel amber caution light illuminates on the crew alerting panel. The crossfeed push button controls the operation of the crossfeed valve. When the crossfeed push button is selected in, the crossfeed valve opens and both electric pumps start to operate. This will cause both green run lights to illuminate. In addition, the fuel crossfeed light illuminates blue on the memo panel. When the valve is open, the flow bar and the push button will be green in line. The crossfeed valve is closed by selecting the crossfeed push button out. This will close the crossfeed valve and the flow bar and the push button will be green vertical. The flow line in the switch is only visible when the crossfeed valve is either open or closed. The control panel on this screen is interactive, so you can open and close the crossfeed valve at will. The fuel quantity indicators display the fuel quantity in each tank. The fuel quantity indicator is powered by the DC essential bus. If the battery is off, the fuel quantity indicators are powered by the ground handling bus when the refuel door is opened. Each tank has an associated low-level amber light. When the fuel quantity in a tank drops below 160 kilograms, the associated electric fuel pump will start up automatically and the amber low-level light illuminates. Click on the Start Simulation button to see the system in operation. When a low fuel quantity condition is triggered, the crew alerting system will also sound a single chime and the master caution lights will flash. In addition, the fuel amber light illuminates on the crew alerting panel. Click on the Start Simulation button to see the system in operation. Fuel quantity indicating system is tested by pressing the Test Push button. Pressing the Test Push button will test both channels of the system. This causes a single chime to sound, the master caution lights will flash, and the fuel light illuminates amber on the crew alerting panel. If the test is successful, the indicators will display all 8s. If the test is not successful, the indicators will display a fault code. The fuel quantity panel on this screen is interactive, so you can test the fuel system. A fuel temperature indicator displays the fuel temperature in the left feeder tank. The indicator is located on the center part of the flight instruments panel. The indicator is powered by DC bus 1. Fuel flow and fuel used are displayed on two indicators located on the lower part of the center flight instrument panel. The fuel flow is indicated by a pointer, whereas the fuel used is displayed numerically. The fuel flow, fuel used indicator is powered by the respective DC bus. After flight, the fuel used indication is reset to 0 by pulling the associated fuel used reset knob. Click on the Fuel Used Reset knob to reset the fuel used indication. This concludes the fuel module.